These notes are on the complex number system. The complex number system is the number system that we use in algebra. So we start from the innermost to the outermost. So back when you were a little kid, you were learning to count, your parents, teachers started and they said, okay, so we count, and we count by, we say 1, 2, 3, 4, etc. So we call these numbers either natural or counting numbers. And somewhere along the way, you said, okay, Mom, Dad, Grandma, I got it, but what about when I have nothing? What do I do? What number is nothing? And so we then said, well, we've got to add the number 0 into our list. So 0, 1, 2, 3, ... And we call these whole numbers. I like to remember that the difference between the whole and the natural is that the whole has the letter O in it, meaning the number 0. So then you went to school, you were adding, subtracting these numbers, and you were like, this is fantastic. I know that 2 plus 4 is 6, etc. But then you got to subtracting and you were like, okay, so I can do 4 minus 1, but what happens when I try to do 1 minus 4? And so we needed another way of representing that concept. And those are our integers. So like -3, -2, -1, 0, 1, 2, 3, ... We call these our integers. And then you started multiplying these numbers. Multiplied, 2 times 3 is 6, 4 times 8 is 32, etc. And then you were like, well, we can also divide them. So 8 divided by 2, 10 divided by 5. But then there were times when the division didn't work out evenly. You did something like 3 divided by 2. And so we needed another way of talking about those numbers. And we talk about those numbers as being rational numbers. And these are any number that I can write as A over B, where A and B, where A and B are integers. And then you went along and you did some more math and you were like, this is so much fun, we love these numbers. And then one day you started talking about circles. And your teacher was like, so we have these things called circles, and we can find the area of them, we can find the distance around the circle, and it turns out that we get a really special number. The mathematicians discovered a really special number every time they tried to figure that out. And then you started doing things like, well, we know that 4 can be, the square root of 4 is 2, but what about the square root of 3? That doesn't simplify. And so we call all of those the irrational numbers. And these are all the ones that cannot be written as a fraction of A over B. And so for this, I'm just going to write some examples. So some examples are pi, square root of 2, something called e that we won't discuss in this course, but that you will see in the future. So then we said, well, we've got all these types of numbers. Let's give the whole shebang here a name. Running out of space. We'll give this whole shebang a name, and we'll call this whole thing, all of these included, call them the real numbers. So when I say real numbers, I'm including every number in this box. And then we got to Math 2, and we were solving quadratics, and we were going along great. We were getting answers like this. We had some square roots sometimes. We had some integers, some whole numbers. Then all of a sudden, we started getting the square roots of negative numbers. And we were a little worried. You know, we were like, oh boy, I think that I may be stuck. Here, I'm going to fix this slightly so that I have enough room. I'm sorry that I didn't leave myself enough room. Make it a little easier in a moment. So again, continuing our story, we got to the lovely place where we had square roots of negatives. And so we needed a new name for those. And so anytime we have the square root of a negative, we know that that has some I in it, and we call these our imaginary numbers. I'm going to draw this a little bit funky for just a minute, and we'll get back to that in a second. We then discovered that, we may have 4i, 10i, 2i, but sometimes we also have like a number being added. So a plus bi. So we call those our complex numbers. And that is the inclusion of our entire number system, at least through Math 2. So any number in our number system can be written as a complex number. A whole number is 1 plus 0i. A natural number, 4 plus 0i. A rational number, 1/3 plus 0i. Irrational number, pi plus 0i. And then we can also have just plain imaginary numbers, 4i, 10i, 20i, etc. And all imaginary numbers are also complex. It just means that my a is 0. So 10i would be 0 plus 10i, etc. It turns out, however, that there is one number in all of these that is both at the same time imaginary and real. And so that number is 0. So the number 0, it's a real number. It's a real number, but it's also an imaginary number because I can rewrite 0 as 0i.